CapeSim has made it a lot easier to solve big thermal analysis problems with SYMMIC in the cloud. Basically, you can launch any simulation into the cloud instead of running it on your desktop. So I'll show you an example here using the X-band amplifier that we've used before. You can either download this example from our website or follow the directions in the user's manual to recreate it from the generic FET template. And what I'm going to do is I'm going to use create device template and take the defaults to create a large single device that's going to have a large mesh. Now, it would obviously be much faster to solve this using superposition, but I could do that on my desktop, but I'm going to just show you how big this problem is running show mesh. So if I look at the console, it says that this is more than 17 million unique nodes. Depending on how many cores we have, that could take a lot of memory, say more than 150 gigabytes of RAM to solve quickly. So what we're going to use is use a cloud instance to solve it directly rather than using superposition. First, you need to create an AWS account, and you can see how to do that from our website or going to Amazon's website. But once you have that account, you'll log into your account and go to the console and go to the EC2 dashboard. That's the Elastic Compute Cloud dashboard. And now we're going to launch an instance. So we say launch instance. Now we need to find the SYMMIC in the cloud product, and it's in the AWS marketplace. So we'll search for SYMMIC. It shows us one product. We'll select it. At this point, we might have to actually subscribe to the product if we haven't done that already, but I already have, so I can just scroll down and continue from here. Now we're going to select in step 2 the instance type that we want to run on. SYMMIC in the cloud has suggested we use R48X large, which has 32 virtual CPUs or 16 physical cores and 244 gigabytes of RAM. So that's probably going to be big enough for our problem, so I'll just keep that selection, and then we'll move on to the next step. This is where we would select where it's going to run in terms of which zone within the region, and we also want to make sure that we're auto-assigning a public IP address so we can communicate with it from our desktop. The next step is to add storage, but we don't need to add any more. We'll just take the default, which is 8 gigabytes of SSD. No need to add tags. For the security group, we'll create a new security group, and the only thing we need to open in terms of incoming ports to this instance is a TCP protocol on port 22, and that gives us the ability to communicate with the instance through SSH. I want to make sure that I select my IP as the source. That means that only my desktop will be allowed to communicate with this instance in the cloud. Now we're ready to launch the instance, but we need to create a public key private key pair that would allow us to do the authentication for SSH. So I'm going to say create a new key pair, and I'm going to call it my key pair. And I want to download it, so I have a copy here that I can use for communication. Now once we have that file, we can say launch instances. So while it's launching, let's go back to our problem, and we'll use the remote run to actually connect and communicate with the instance. So we're going to run this template X-band amplifier export, and we need to fill in the rest of the dialog in order to do the communication. So the information we need is in the EC2 dashboard under the running instances. So we'll select the instance that we just started up, and we'll scroll down and look at the IP for public IP address. We want to copy that, and then we'll go back to the dialog and put that in as the host IP address for our remote run. We're using port 22 for SSH communication, obviously. The username for these cloud instances is EC2 user. We don't need to put in a working directory. We'll just use the home directory by default. Now we need to use our private key file that we saved, so we'll select that. Now we can say connect. Now it says that it doesn't know the fingerprint. We don't have a fingerprint for this yet, so I'll say go ahead and connect anyway, and then I'll copy the fingerprint and put it in this box so that we can use it later if we want to launch another job. So we push the launch button, and what happens is SYMMIC uploads the template and any other files that the template needs and starts running the job in the cloud. Now we just have to wait for this simulation to finish, so I'll just skip ahead to that. So it's been about 20 minutes so far, and I just want to mention that while this is running, we can close the remote run dialog as long as we don't exit SYMMIC. If we were to exit SYMMIC, it would actually cause the simulation connection to be broken to the instance, so we would lose our simulation results. We have to maintain SYMMIC until the remote run job completes and the results are downloaded. So it obviously would have been a lot quicker to run this in superposition, and we could have run it in superposition even on the cloud instance. But once this simulation finally completes, then it will download the solution results into our desktop machine for final analysis. Now that the download's complete, we can close the dialog and load the solution. Now, if we're not going to run any more jobs on that instance, what we should probably do is go back to our dashboard and actually terminate the instance so we don't incur any additional charges. So our solution is loading, and there we see that we've got the answer.